Check this out. It's a chemistry textbook by Cengage, 10th edition. Let's see. So we got chemical foundations, atoms, molecules, and ions, stoichiometry, chemical reactions, gases. You know that there's the A, B, C, D, E, F, G's of gases. I got a video on that stuff. Thermochemistry on my favorite topics. Atomic structure, the Bohr model, quantum numbers, periodic trends. Nice. Bonding. Okay, so yeah, electronegativity and like different kinds of structures. Yeah, orbitals, covalent bonding, liquids and solids, properties of solutions. Ooh, there's more. We got chemical kinetics, equilibrium, acids and bases, electrochemistry, batteries and galvanic cells. What the hell is all this? The nucleus. Ooh, some nuclear physics. Let's just see how much fun this textbook is. Significant figures. That was totally the most boring thing to do. Our chemistry teacher was crazy about those sig figs. That was like the main reason I got everything wrong. Who's that? Oh, Ernest Rutherford. Remember the gold foil model? That was fun. Moles of atoms. Usually the math kind of looks like this. You're mainly just canceling things out and ending up with some sort of answer over here. Interesting problem. Consider the hypothetical reaction between these two going on. Balanced equation, limiting reactant. Oh my god, the limiting reactant problem. I don't know if we ever had those ice tables. Enthalpy and calorimetry. This is thermochemistry. Oh my god, this is like the best topic. Combustion Hess's law is really complicated to deal with the like adding up the H's on both sides. Atomic structure and periodicity. This is the probability, the distance from the nucleus. So there's a high probability it's going to be found around here and a low probability over there. That's pretty cool. So already getting into quantum mechanics. This is a different way to add up the energy changes by using sort of lattice energy, electron affinity, ionization energy, resonance. I think that's going to be like the structure that you can sort of form in multiple like ways or something. Chemistry is a little bit more sort of knowledge-based. Physics is more math-based. Chemistry is more knowledge-based. Oh, hot peppers. I like hot peppers. I just learned that if you eat hot peppers, your brain tells you that you're in pain and that you're having issues, but it's just in your mind. Once I got to hybridization, I kind of gave up because it just got to be too complicated. There was just so much stuff. Like, these are different ways to form orbitals, and there's like different ways to form like take the same compound and form it in a slightly different orbital way, and it gets really confusing. Oh, what is this? This is, so when pressure increases, vapor pressure increases, and it's like diagrams of different pressure points. The rate of reactions here. Rate law, concentrations, plot for the decomposition reaction. Interesting. Apparently these are liquids that contain acids and bases, juice, sodas, and then over here we have more stuff that has acids and bases, like Drano, bleach. So what's going on here? If we take a solution, add cold HCl, get a precipitate, add some heat, precipitate or solution. I don't know what this flow chart is going in two different directions. Separation of the group 1 ions. Apparently there's a spontaneous reaction that goes this way and a non-spontaneous reaction that goes the other way. What? Nucleus. Nuclear reactivity. Let's check this out. Radioactive decay, stability, transformations, thermodynamic stability. So this is the number of protons and the number of neutrons. And apparently we see that stable nuclides in a zone of stability. So too many neutrons over here. If you have too many neutrons, you become more unstable. Radioactive decay is just nuts. You could just go from here and all of a sudden you're here, and then all of a sudden you're here. You just poof, turn into iron. What? Mass number, binding energy for the nucleon. Well, that's weird. So as the mass increases, the binding energy actually starts to decrease over here. That's weird. So as the atomic number starts to increase, the radius decreases a bit for a moment, but then eventually towards the end, it gets a little bit longer. Probably because maybe the outer portion, the portions are sort of like squeezing it, and so it's trying to shrink the radius as you add more. Steel making. Molten metal. So we got air going through here. Molten metal here. We got a tap hole. Hydrocarbon derivatives. Yeah, we all know we like these things right here. Alcohols, ethers, ketones, esters, butane, propanol, propane. Got this. Amines. Oh yes, the organic chemistry. Well, that is indeed basically what this book's all about. Reduction potentials, values of Ka. What the heck is that? KB, Ka, KSP.